So for the next example, we're going to do some more U substitution. And like I said, these are usually rigged up, so it's kind of easy to do. So for example number 6, they want us to find the indefinite integral of cotangent of 7x dx. And again, what we want to do is we want to try to figure out a way, easy way to kind of integrate this. This is not overly complicated, but you know, by using U substitution, it'll help. So just to kind of refresh our memory on that, what I really want to do is, right now I have this written in the form of f of x dx, right? So I've got like, well actually it's like f prime, if you want to think of it like that. And so what I want to do is I want to, through U substitution, take like the indefinite integral of another function of u du, and hopefully this is easier, right? Our goal is we choose u in such a way that taking the derivative of f of u is easier than the f of x. All right, so this one's kind of hard, this is easy. And so cotangent of 7x, well, this is going to seem weird, but really, when you run across this, this is really the same as cosine of 7x all over sine of 7x dx. And notice that cosine and sine are derivatives of one another, right? So then we have to arbitrarily choose to try to figure out which would be easier for us to do. And then we also have to deal with this 7x business, okay? So what we could do is, what would you guys choose? What might be a good way to choose u? We could either choose sine of 7x or cosine of 7x. Well, if I choose sine of 7x, I'm probably going to have like du over u, and do we know the derivative or the antiderivative for 1 over u? Yeah. So if I choose, if I take and I let u equal sine of 7x, then du is, now this is the interesting thing, we're going to have cosine of 7x, but remember, because of the chain rule, you've got to tack on a 7 in the front. So then this next indefinite integral becomes, oh wait a minute, I have cosine of 7x, so what do I do to get rid of this 7 here? Just divide both sides by 7, right? So if I divide both sides by 7, these 7's cancel, and cosine of 7x is actually du over 7. So I'm going to get du over 7 times u, right? And technically there's a dx on the end of this because it's du dx, and I toss that to the front.
Okay,
so,
wait, I'm confused.
Or to the back.
I'm confused why you put the du over 7 right there.
Because this is cosine of 7x. But my derivative, du, is 7 cosine of 7x.
So what happened to the sine of 7x?
That's just the bottom. That's just u.
Oh, okay, I see what, okay.
Actually, it's 1 over u, right? So I'm getting a little, I'm trying to do two things at once. So that's actually 1 over u, right? Because sine is on the bottom.
Okay.
So now, if I want, I could do some use the commutative property of multiplication, and I get something like this, right? And I could take this 1 over 7 and toss it to the front. So in the next line, I've got 1 over 7 du over u. So before I move any further, does that make sense to you guys? Do you have any questions as to how I got what I've got on the board?
So that's the antiderivative.
Well, no, we haven't.
That's the beginning.
That's the beginning of it. Yeah. Yeah. So this was conveniently rigged up. So let me, before I actually take the antiderivative, let's go through this. And it's really easier than trying to find the antiderivative of cotangent of 7x. It really, truly is. We start off with f prime of x dx, and we want to integrate that. And you could say f of x. You don't have to use the prime notation. I'm using it to let you know that we're going in the opposite direction. So I remember that cotangent is the same as cosine over sine. Cosine and sine have that differential relationship where sine differentiated becomes cosine, and cosine differentiated becomes negative sine, and so on and so forth. So I can choose one of those to be u and the other one to be du to some degree. Now I chose sine to be u because I don't want du in the denominator, right? Because I want du up here. I don't want it in the denominator. So I want some sort of function of u, and then I want du on the top of the fraction. So that's why I chose sine of 7x to be u. Then when I differentiate that, I get 7 cosine of 7x. However, there's no 7 here. So I want to substitute only cosine of 7x. Well, plus the dx, right? So I want to substitute only that. That means I need to move my 7 away to the other side of the equal sign. How do I do that? Divide both sides by 7. So when I go to substitute cosine of 7x dx, in other words, all this stuff here is going to be replaced by this right here. And 1 over sine of x was replaced by this stuff here. By applying the commutative property of multiplication, I've got a constant multiplier that I can now toss to the front due to the properties of integrals, right? So I did all that work to take an easy derivative. Well, we know that the derivative of u prime over u is simply going to be the natural log. So we've got the 1/7 tossed to the front, but then the derivative or antiderivative of this is the natural log of the absolute value of u. We don't have an upper or lower boundary, so we're just going to tack on my plus c at the end. Right? Now what is u?
Sine of x.
Sine of x.
Sine of x.
So I've got the natural log of the absolute value of sine of 7x. Did I write the 7x or just, yeah, I did. I sure did. 7x plus c. And then, oh, I almost forgot I got to tack on this 1/7.